Hello, wonderful physics students. This is just a little video on practice and translating between velocity time graphs and position time graphs. Okay, so let's take a look at some graphs. So here is a velocity time graph. So you know it's a velocity time graph because it says velocity. And down here around where it says extend page, it says time graph. Okay, so let's look at what this graph is telling us. It tells us for the first 3 seconds, so remember the horizontal axis is time in physics. For the first 3 seconds, we are going 4 meters per second in the positive direction. And for the next 2 seconds, 3 to 5 seconds, we are going 2 meters per second in the positive direction. And then for the last 1, 2, 3, 4, 5 seconds, we are going backwards because it's negative. So we're going backwards at 1 meter per second. This is constant velocity because this part is constant, this part is constant, and this part is constant. All right. So let's see. All right, so now we have, it's hard to read, so I will write this up here. We have a velocity time graph here. So this is the time axis right here. And this is in meters per second. And this is a position, so we'll just call it x, time graph, which is in meters. This is time, and they're both in seconds. Okay, so this is the exact same graph that we had before. So now, how do we figure out how to draw the position time graph given a velocity time graph? Well, let's see here. We are not given where to start. So we could start anywhere we like. Just because I want to, let's start at x equals -2 right here. Just so we don't start at 0. I don't want you to get into the habit at starting at 0 all the time. So velocity is equal to change in x over change in time. So if we multiply both sides of the equation by change in time, velocity times a change in time is equal to our displacement, change in x. This only works if velocity is constant. So for the first 3 seconds, so we'll call this part 1, our velocity is 4 meters per second, and our change in time is 3 seconds. So our displacement is 12, the seconds cancel out, meters. Okay, so if we start at -2 and we're going to go 12 meters in 3 seconds, that means we'll end up at 10. So 2 plus 10 is 12. We're going to go positive 12 meters in 3 seconds. So draw that line. The slope of this line equals 4 meters per second. Ta-da! Okay, so let's try part 2. So now we are up here. First, you ask yourself, are we going forward or are we going backwards? So we're going forwards. So this is part 2. Going forwards because the velocity is positive. So we do the same thing. Velocity is change in x over change in time. Multiply both sides by change in time. Velocity times the change in time is equal to change in x. So the velocity here is 2 meters per second, and we're only going to go this velocity for 2 seconds, 3 to 5 seconds. And this is going to equal our displacement. So 4 meters is our displacement. So for part 2, we're right here at 10. I want to go up to 14. 14 right there. In 2 seconds. And that. So the slope is 2 meters per second right there. And you could tell the slope of the line changed. It was steep, and now it's not so steep. Now for part 3, so here's part 3. This is part 3. I just wrote part 3 outside the box right there. Oops. There we go. Same deal. Velocity is equal to change in x over change in time. Velocity times the change in time is equal to change in x. A velocity is -1, so it's going backwards. The time is 5 seconds. So we have 5 meters, -5 meters is our delta x. So we are at 14, and we're going to go backwards 5 meters, which will bring us down to 9 meters at 10 seconds. And the slope was -1 meters per second. So that is how you go from a velocity time graph to a position time graph for constant velocity. All right, so now let's go to the next page. Okay, so I have a new velocity time graph right here, and so I'm asking you some questions. What is the displacement for the first 5 seconds? So for the first 5 seconds, we have 2 kinds of velocity. You could always draw your boxes from the time axis to wherever your constant velocity line is. Now, part 1, part 2. So velocity times a change in time is equal to our displacement. So for part 1, a velocity is -5 times the change in time, which is 2 seconds. And this is equal to -10 meters. Now notice, if you multiply 5, which is here, so 5 times 2, it's the area. So we call this finding the area under the curve. You hear me say that at some point. The area under a velocity time graph gives us our displacement. Let me write that. The area under a velocity time graph gives us our displacement. Okay, so let's do part 2. So part 2, let's just do it finding the area. So here's the area for part 2. So the area would be the length times width, so 1, 2, 3 is the length, and the width is 1, 2, 3. So 3 times 3, 3 seconds times 3 meters per second is equal to 9 meters. So what is the displacement for the first 5 seconds? So -10 meters plus 9 meters is -1 meter. That's our displacement. What is the total distance traveled? Okay, so if we're looking at distance traveled, from part 1, our displacement, our change in x, is -10 meters. but our distance traveled is just 10 meters because it's always just positive. Our displacement and distance in this case is 9 meters because they're both positive. And in this case right here, it's negative. Our displacement will equal -1 times 1, 2, 3, so -3 meters. So our distance traveled is 3 meters. So our total distance traveled is 9 plus 10 plus 3, which is, I believe it's 22 meters. So be careful when you see distance or displacement. Okay, what must the velocity be for the last 2 seconds, from seconds 8 to 10, for the total displacement to be 0 meters? Okay, so now we're looking at displacement. So displacement so far we have -10 plus 9 plus a -3, because those are our displacement values that we just found. So 9 minus 3 is 6, -10 plus 6 is -4. So with what's drawn, our displacement is -4. So we need a +4 displacement, -4, to make it 0. So with what is drawn, we have a displacement of -4. So we need something with a +4 displacement to cancel out this -4. Alright, so let's look. So it's over 2 seconds. So +4 meters over 2 seconds gives us our velocity, 2 meters per second. So our velocity for the last 2 seconds needs to be 2 meters per second. And so our change in x is 4 meters. And if we add up our displacements, we will get 0. Yay! Okay, so now let's do the position time graph and we'll be done. So let's start this graph at -4. Let's just start at -4. We'll start at -4. So again, the area under the curve is -5 times 2, so it's -10 meters. The displacement for the second part 2, is 1, 2, 3 times 1, 2, 3, so this is +9 meters. This will be -3 meters, and then we'll go ahead and just do that 2 that we solved for just now. And so we'll say that is +4 meters. Okay, so -4. Oh, well, let's look at this. We can't go backwards to begin with if I start so low. So let's not start that low. So let's start at 10, because we can. I didn't tell you where to start before. So if we start at 10, in 2 seconds, we're going to go down 10 meters. So we're going to go from 10 to 0 in 2 seconds. And then, in 3 seconds, 1, 2, 3, I'm going to go up to 9. I should mark that a little bit better. And then we're going to go down 3 in the next 3 seconds. So 1, 2, 3, that's at 6, and 1, 2, 3, 3 seconds. And then we're going to go up 4 in the next 2 seconds. So 1, 2, 3, 4, 1, 2. And if you notice, We start and end at 10, so our displacement is 0. So that's excellent. And